Right, 2.2, calculus 30, number 4, finding an equation of a tangent line to the curve at a given point. So this is really the first time that you've done something like this. I've given you the equation, and I've also given you a point. And so I need to find, I need to look at the equation of the line. Okay, whatever that line is, it's going to be something like this. Okay, and I need to find the equation. So we need the slope, we need the y-intercept, that sort of thing. Okay, it's going to be to a curve. Okay, so what is this curve? Actually, I don't know what this curve looks like. Anyways, but we're going to find a line. Look at the equation of the tangent line. So here's the function. This is where I started. Okay, I rewrote this as fractional exponent, so we could use the power rule. Is that better? So we could use the power rule. Is that frozen? Okay, sorry. So from here then, we find the derivative using the power rule, and this is what we get right here. The derivative is this right here, 1/3 x to the power of negative 2 over 3. Now at x equals negative 8, you simply plug in negative 8 in for x. You don't have to simplify this at all. You just want to find the number. That is the value of the slope, right? The value of the slope. So you put your x value of the given point, that's the x value, the point of tangency, into your function here, into your equation of the slope. And you should get negative 1/12. Okay? Remember how to interpret or how to use these fractional exponents. The 3 is a cubed root, right? This 3 here is in the denominator of the exponent. That's the cubed root. And the 2 is the squared part. So the cubed root of negative 1/8 is negative 1/2. You square that and you get 1 over 4 times 1 over 3 is 1/12. So there's the first step. Well, actually, here's step number 1, right here, getting the derivative. Step number 2 is getting the slope. Step number 3 is using the point-slope form, because you have a point that's given up here, and you have the slope. You just determined that down here. And you put it into the point-slope form, and then you can come out with an equation. So here's the equation in y equals mx plus b form. You just got to do a little bit of math. Gather some like terms, blah, blah, blah. And this would be, I guess, general form here. Okay? So the back of the book may give general form, I believe, for a bunch of these. So if that's the case, then you have to change your version. If it's y equals mx plus b, you might have to just kind of change it to the general form so you can check to see if it matches with the back of the book. Okay? So, again, the steps are pretty straightforward here. Find the derivative always, because tangent line, right? We need the slope in order to go to the equation. So find the derivative, plug in your x value into the derivative expression and get the slope. Then plug your point into the point-slope form and rearrange as needed to find the equation of the line. Okay? So that's for 4D. Hopefully that'll give you some tips on how to do the rest of 4 and any question that asks you for the equation of the tangent line. Okay, so I did graph my original function here, and I graphed this tangent line here over here on Desmos, so if you want to take a look. So this red graph right here, kind of crazy, but that is y equals the cube root of x right here. And here the blue line is the equation of the tangent line that we graphed, and you can see at negative 8 is the point of intersection here. So that's where this blue graph does touch the graph there. So this is the correct equation for the tangent line. Does that make sense? Okay. So certainly you do have, your graphing technology or your whatever Desmos online there. You have that at your disposal. So once you do something like this, feel free to check everything out online. Graph this. Graph the equation that you've gotten. Now you do have the answer key as well, but in a case where you're doing something you don't have the answer key for, just test it out. Graph it and see if it makes sense. Okay, any questions or thoughts?